Now, the goal of the tutorial is to give you hands-on experience, but it's a fully documented tutorial, so if you don't have the environment, you can also read it and fairly quickly see what the commands are, what the output would be, and you'll get the same results that way. But if you can get an OpenShift instance to run on and run through it hands-on, I think it'll really reinforce your learning, prove to you that the SCCs do work the way you expect them to, and also it gives you an environment and a method to test your own. So we'll stick to a fairly simple example that's a common one, where you care about what user ID and what group ID you're using, and you need a file system group ID to access a volume. But in your own application, you might need other capabilities. You might want to see what root and privileged containers look like. And you can use the same method to either log onto a container and run some commands to test it, or run your app and look at the logs to see if you're really restricting the capabilities the way you intended or allowing them as needed. So this is the tutorial on developer.ibm.com under a learning path called Secure Context Constraints OpenShift. And if you jump from that tutorial down, from that learning path down to the tutorial, you can walk through this and copy all the commands. So I'll skip over some of the introduction and focus on the steps. The first step, though, which I've already done, is clone the GitHub repo. As you go through the tutorial, there will be YAML files. You can either download them individually or copy, paste, and edit files. Or if you clone the repo, they'll be right there in a directory, and you just run the commands. So as I run through this, that's what you'll see me doing. I simply run a command, and the YAML file will be right there in my directory. I'll try to go through this much faster, but if you have time to go through and explore, you could take up to an hour doing this. So the steps. The first step I'll be going through is creating a default deployment. So this is a simple base image, and it just runs and keeps running. I'll log in and see what kind of security context and what security context constraint it's using. Even though we're not asking for anything in particular, it will get assigned a security context constraint. The second step will be to attempt a deployment where I request a specific user ID and group ID and file system group. Without any specific security context constraints to allow it, that one will fail. So we'll get to prove that security is working. The next step is I'll show you how to create a custom SCC that allows that, and we'll bind it to a service account. And finally, we'll deploy again using that service account, and we'll see that the SCC was used and our security context was granted, and we're actually running with the user ID, the group ID, and the additional groups we need to write to a shared volume. So I'll jump down to the first step. So this will be my default deployment. So the first thing you need to do is log in. If I look at my OpenShift, generally what I do is I'll copy the login command from here. I'm not going to do that right now because I don't want to share that, but I've already logged in, and then you can create a new project to work in. A new project, and it should have already put me in the project like it probably says right there. Already on project demo. So for the first step, this YAML file is my example instance. This one I'm just calling default. It's just a minimal container, and it's just running. It says hello, and it mounts a volume at var opt app data using the default service account, and that's all it does, and we'll run that and take a look at it. So here, if I copy the command, OC create and the deploy default YAML. There we go. Now, using the command line, you can look at what you get when you created that. What I'll do here is I'll look at the pod based on a label. There will be quite a bit of output to this one, so I don't think I want to walk through that. But if you look at the tutorial, I highlight the sections that are interesting, and I'll show you in the UI as well. From that output, describing the pod here, the parts that are interesting to us today is it will show you what SCC was selected. So it used a restricted SCC. It includes a spec that has a security context. So we didn't ask for this, but by default, it said, don't let them use kill, make node, set group ID. If I want to do the same thing in a much more visual way, I can use the OpenShift web console. And from there, there's an administrator perspective where you can see your deployment under workloads, and you can see that it deployed a pod. And when we look at that pod, we'll be able to see the details under YAML. And what we'll use later is we can look at the logs and the terminal. So if I jump to that, select my project, and under workloads deployments, you'll see there's a tutorial that was just created, the SCC tutorial deploy default. It has one pod. So if I go to that pod and I check on the YAML, if I scroll down a little bit here, you can see where it shows you, that it shows the restricted SCC. So we didn't do anything in particular for that, but it will assign the most restrictive SCC it can, and that's the one we got. So the pod is working, but it's with those restrictions. And also, if I scroll down, similar to what I showed you in the edited output earlier, when you get down into the details of the pod, you should see there's its name default. Here's the service account name. It's running under the default service account. That'll be interesting to us later. It was assigned a pod security context, and this FS group is usually this large number on OpenShift. And the container has its own security context, which has a run as user. It has those drop capabilities I showed you earlier. It mounted a volume. And I don't want to scroll too much, so I guess I'll jump back to the tutorial. Here's what I wanted to look at. So the FS group, that's the one I skipped over. That was up under the pod security context. That will be interesting when we try to access the volume. Okay, so I showed you here's how you can get the information from the command line. Oh, this is actually the remote shell. So this is how you can run remote commands on the container on the pod from the command line. But I think it looks a little better using it in the console. So I'll access the terminal tab in my console. And we'll run some commands just to prove that the container is running as we expected. So I can actually log into that container. I'll run who am I and an ID to see how we're running. And then I will take a look at some of the access we're given on the volumes. So that's the user ID I was given when I didn't ask for anyone in particular. It comes from the project on OpenShift. So you'll notice the ID is this large number. The group is the same, but it has a group ID in root. And the list of groups it can access is root and this one that matches the user ID. And how that affects us when we're writing like to a volume or to temp or to root, I can test like this. So first I'll echo hello to the volume. Next I'll echo hello to a file on temp. And finally, I'll echo hello to a file on the root directory. And notice that one was permission denied because I'm not root. So let's take a look at what we got. Again, this is just with the default container, the default security context that gave us a restricted SCC. You notice the files I wrote. This first one that I wrote to temp, it's owned by that user ID that I was assigned, but the group is root. On the other hand, when I wrote to the volume here on var op data, again, it's owned by me, but this time its group is assigned the group ID that matches my user ID. Now let's try it with an SCC. Actually, first with the security context that we'll request. So in the next example, what we'll do is we'll say, look, I want my container, it's the same container, but I want it to run as a specific user, not that big, 1082, whatever. So user 123, and I need to run in group 5678. And when I use this shared volume, maybe other containers are using it, or maybe it's a real shared file system. So I'll have a file system group of 5555, and just because I'll have some extra groups that I'll use for whatever, 5777, 5888. So next I'll create that one and we'll see what happens. So if I do my OC create with this YAML deploy SC, looks like it worked. I've shown some commands here though to describe the deployment. And ultimately what you see is even though the deployment was created, there was a replica failure. And you can get additional information about what happened. The error is actually in the replica set. I'll paste the command here, but there's an easier way to look at it. See, there's a good error message right there. If I go to the web console and I look at my deployments again, notice I have a second one with the SC. I got 0 pods because it didn't really work, but I did get a deployment. It has a replica set. And if I look at the replica set, the events will clearly show me what happened. And the error is invalid user 1234. It wants it to be in this range that was assigned to my project, so that wasn't allowed. We also asked for 5555 for the file system group, and that was out of range as well. So next what we'll do is we'll fix that with a custom SCC. So step 3 is to create and assign the SCC. So here you'll see the YAML that describes the security context constraint. We called it SCC tutorial SCC. Not very creative, but it works. So this will give us a user range from 1000 to 2000. So that'll allow 1, 2, 3, 4. Down here for the FS group, we're saying it will allow between 5000 and 6000. That'll allow us that 5555 that we wanted. And our supplemental groups will also fit in that range. So you'll see the 5777, 5888. So first let's create that SCC. So this just creates this thing we described in the YAML file. And I've run this a few times, so it says it already exists. Next, we're going to create a service account. So when you run a deployment, it doesn't just run as your user, it uses a service account. If you remember, the first one we used ran as the default service account. This time we'll run as a custom service account that I'm creating right now. Or perhaps I created it earlier, but we'll run it again. Okay, it's created. Now, in order to allow this service account to use the custom SCC that we just created, we need to bind them together. And we'll do that here with RBAC. If you look at this YAML file, you'll notice the SCC tutorial SCC thing that we just created. It's a security context constraint. We're going to grant use of that SCC to our subject, and our subject is the service account called SCC tutorial SA, which is the one we just created. So now what I'll do is I'll use this RBAC YAML, and I'll run create on that. Now I have a service account with a security context constraint that will allow me the security context I need to run my container with 1, 2, 3, 4, 5, 6, 7, 8, and a file system of 5, 5, 5, 5. So that's what we just did. Step 4 is to prove it. And in this case, we're proving that the SCC, we failed earlier. Now we're going to succeed. So you'll really see how it works. And you can use the same method with your own requirements for additional privileges. But this is a good way to get started. So the deployment will be the same one. This one's called SCSA, but it's the same hello from user. Run as user 1, 2, 3, 4, group 5, 6, 7, 8. The same groups, especially the file system group. So I will create the deployment. Again, you can look at it from the command line if you need to see that it's doing what you wanted it to do as far as getting the security context. But we'll go into the console, and you'll see, first of all, that it worked. The pod's running, because the previous one it failed. Next, what we'll look for is, did it assign the SCC? Is it using the service account and the groups that we expected? And then we'll come down here and we'll test it. So I go back to my deployments. SC with SA. The pod is running. We can take a look at the pod. We see the name is the one we expected. And a lot of scrolling sometimes. It's using the service account that we wanted. The security context has the groups that we needed, especially the file system group 5555, and the container itself running as 1, 2, 3, 4, 5, 6, 7, 8. And the part I skipped past was what SCC did it use? That's usually around here. I can't seem to find it. Let me go back. This should help show you what to look for. Oh, it's way down around line 163. The lines will definitely vary, but I was looking for it near the top. I'm looking for, I'm sorry, around line 26, the SCC. This is where I thought I was looking. Under annotations. Well, I can't seem to find it today. Okay, well, I want to move on, but you can always find the SCC in there somewhere. It will show you the OpenShift IO SCC. But the more interesting part here, in interest of time, is to show that it actually works the way we expect it to. So again, I'll test this in the console, running who am I in ID, and then let's see if the file system is working the way we expect it to. So if I go to the pod, who am I? You'll see that we got the user that we, for whatever reason, this application is going to need, and it's running in the group that we think we need, 5, 6, 7, 8. So our custom service account was allowed to use our custom SCC to let us work with these groups. And we're also part of this file system group that's important to us, 5555, and the extra ones that I'm not really using right now. So if we look at how this affects writing to our file systems, you'll see that the root file system is still restricted. The temp file system is still pretty wide open, but the volume that we mounted and we want to share, now it has the group 5555 that we felt we needed to share this with other people. And you'll notice the group security, read write with a sticky bit. That's what that S stands for. So we'll be able to write and share files in that volume. And we'll test it out again. So first let me do the echo hello. Sorry. And I'm trying to make sure I get my copy pastes right. This part of the demo I usually fill somewhere. And we can't write to the root directory. That's good. We're not running as root. Let's see what the files look like. Now if we look at the files we created. In temp, sure, we created a temp file under our user 1234, but now our group is 5678. So this is what we're running as. This is how we're working, like for temp files in an application. But I've got this shared volume, and I want to share it with other containers. Maybe it's a real shared file system. I'm still writing as myself, 1234. I was allowed to because I'm in 5555. Not only that, but I wrote this file and look at the permissions. I can read write to it, but anyone in that group 5555 can read from it. So I effectively shared a file in a volume that other users, the other user IDs, but the same group ID can share. That's how you get file systems working across containers. And we controlled that and secured that using SCCs. So that wraps up the tutorial. I hope you get to go through this and run it hands-on, as I mentioned earlier. Definitely at this point, you'll see how you can create containers and test them using a terminal. If you're creating a container that runs your own app, you might be able to test some of those privileges from the command line, like ID and who am I is always good to start, see where you're at. But in the case of your own application, you might be more interested in, does it run, does it fail, does it crash, or does it write something to a log file that says, I failed to write this file. So you can get in there and test things this way, create your service accounts, create your SCCs, and prove yourself that it really works. I think the hands-on tutorial will really reinforce your learning and help you learn security context constraints on OpenShift. Thank you for watching, and good luck.